Hello, good evening, respect judges, lecturers, and fellow participants. My name is Rosikhotul and I am from the Department of Mathematics, University Islamic Negeri WALISONGO, Semarang. Today, I am honored to present my project entitled Implementation of RSA Cryptography for Secure Student Identity Verification using QR Code. Presentation outline a structured walkthrough from cryptographic theory to practical implementation. 1. Cryptography fundamentals. Definition, objectivities, and the encryption description cycle. 2. RSA cryptography. Public key principles and the mathematics of number theory behind it. 3. QR code and its security gap. Why conventional QR code cannot protect confidential data. 4. Proposed implementation. 6-stage system combining RSA encryption with QR code storage. And 5. Role of RSA and conclusion. How RSA graduates confidentially across the whole process. This project demonstrates how pure mathematics, particularly number theory, can be applied to solve real-world problems in digital information security. Specifically, I propose a system that combines RSA cryptography and QR code technology to protect student identity information from unauthorized access. Introduction and backgrounds. Digital identity is increasingly stored and verified through compact, sign-readable format such as a QR code which can be scanned instantly by any smartphone camera. A conventional QR code, however, simply stores information as plain, readable text. Anyone who scans it, authorized or not, can immediately view the encoded identity data. This creates a real risk when QR codes are used to carry sensitive personal information, such as a student name, identification number, department, and faculty. This research addressed that gap by applying RSA cryptography, a well-established public key algorithm grounded in number theory, to encrypt student identity data before it is embedded into a QR code. Before discussing RSA, let's first understand cryptography. Cryptography is the science of protecting information by converting readable data, called plain text, into unreadable data, called ciphertext, using mathematical algorithm. The word cryptography comes from the Greek words kryptos, meaning hidden, and graphin, meaning to write. Therefore, cryptography literally means the science of writing secret messages. Today, cryptography is widely applied in online banking, digital payments, cloud computing, secure communication, digital certificates, electronic signature, and digital identity system. Without cryptography, sensitive information transmitted over digital networks would be vulnerable to encryption and misuse. Objectives of cryptography. Cryptography is built around four foundational security goals. 1. Confidentiality ensures that information can only be accessed and read by parties who are authorized to do so. 2. Integrity ensures that information is not altered, tampered with, or modified during storage or transmission. 3. Authentication verifies the true identity of the parties involved in a communication or transaction. 4. Non-repudiation prevents 4. Non-repudiations prevents a user from letters denying an action or message they have genuinely performed or sent. This slide illustrates the basic cryptographic process. Initially, the original message is called plain text. The plain text is encrypted using an encryption algorithm and a cryptographic key, producing clear text, which is untearable. This clear text can then be transmitted securely. Finally, the authorized recipient performs decryption to recover to the original plaintext. This simple process ensures that sensitive information remains confidential throughout communication. RSA cryptography overview definition. RSA reverse Samir Agreement is one of the most widely used public key cryptographic algorithms introduced in 1977 by Ronald Rivers Adi Samir and Leonard Adleman. Unlike symmetric cryptography, which use one shared secret key, RSA employs two mathematically related but distinct keys. Public key, freely shared and used only during the encryption process. Anyone can use it to encrypt a message. Private key, kept strictly secret and used to recover the original message through description. The security of RSA rests entirely on concept from number theory. Prime numbers, integer factorizational, greatest common divisor, Earl Totit function, modular arithmetics, modular inverse, modular exponentiation. The first stage of RSA is key generation. First, two large prime numbers, P and Q, are selected. Next, we compute the modulus n equals P times Q. Then, our Totian function is calculated. After that, we choose the public exponent E, ensuring it is relatively prime to the Totian value. Finally, we calculate the private exponent T, which satisfies a modular inverse relationship. The result is a pair of mathematically related key, the public key used for encryption and the private key used for description. RSA working principle, encryption and description with the key pair and established RSA used two elegantly symmetric formulas to protect the recovered message M. Encryption C equals M to the power of modulo N. Description M equals C to the power of D modulo N. Because encryption and description rarely two different mathematically linked keys, only the intended recipient, the one holding the private key, can ever recover the original message. What is a QR code? Definition: a quick response, or QR code, is a two-dimensional barcode capable of storing various forms of digital information, including text, URLs, identification number, and encrypted data. Why QR codes are widely used? Large storage capacity for digital information, fast scanning using ordinary smartphone cameras, high reliability through built-in error correction, broad compatibility across device and platform. The QR code security gap. A conventional QR code provides no built-in data protection. Whatever is encoded can be read by anyone. Conventional QR code plain text. Consequences of no protection. Personal identity data is exposed to anyone with a scanner app. Information can be copied, shared, or reused without consent. QR pass can be duplicated or forget more easily. No mechanism exists to verify that the scanner is authorized. Confidential information requires an additional security layer before being encoded. This overall architecture of the proposed system. First, student identity information is collected. Next, RSA encrypt the information. The encrypt her text is then stored inside the QR code. Anyone can scan the QR code, but they will only see keep her text. Only authorized university staff processing the private key can decrypt the information and verify the student identity. Thus, the QR code functions only a storage medium, while RSA provides the actual security. Implementation stage 1 to 3. The system pipeline begins by collecting identity data and preparing it is secure storage. Stage 1. Student identity input. The system receives the student identity information, student name, student identification, number, department, and faculty. Stage 2. RSA key generation. The system generates a matching RSA key pair, a public key and private key. Practical implementation use RSA 248 to meet modern security standard. And stage 3 RSA encryption. The student's identity information is encrypted using the public key, transforming readable data into keep her text. Implementation stage 4 to 6. The keep her text is then embedded, distributed, and finally verified only by those holding the private key. Stage 4. QR code generation. The keep her text is encoded into a QR code. Unlike conventional QR code is no longer storage readable information, only inscribed keep her text. Stage 5. QR code scanning. When scanned using an ordinary QR scanner, the code reveals only clip her text, never the student's actual identity information. Stage 8. Stage 6. Description and verification. Authorized university offers use the RSA private key to decrypt the keep her text and compare the recovered data with the university database. In this project, RSA is much more than an encryption algorithm. It serves as a primary security mechanism. RSA encrypts student identity information, protect confidential data inside the QR code, prevent unauthorized disclosure, and ensures that only authorized users then cover the original information. Most importantly, RSA demonstrated how number theory can be applied directly in modern digital information security. Conclusion: RSA cryptography can be successfully applied to protect student identity information before it is stored in a QR code. By storing keep her text instead of plain text, the system ensures that an authorized user who scan the code obtain no meaningful information. Only authorized university offers holding the RSA private key and decrypt the data and verify a student identity against the official database. In conclusion, this research successfully demonstrates that RSA cryptography can effectively secure student identity information before it is stored inside a QR code. Instead of storing plain text, the QR code stores keep her text, preventing unauthorized users from accessing confidential information. Only authorized university officer processing the private key and decrypt and verify student identities. This project illustrated a practical implementation of pure mathematics, especially number theory, in digital security system, which aligns closely with the theme of the International WALISONGO Science Competition. Thank you very much for your attention. Assalamualaikum warahmatullahi wabarakatuh.